Okay, so in this section, we can talk about trigonometric equations. So now we're going to take what we've been learning, and now we're going to take it to see how we can solve equations involving trig functions. We'll start first by looking at examples where we're just plugging in, and then we will go further in depth. So in this first example here, it says use substitution whether the given x value is a solution. So we're literally just going to plug this in. So we want to know cosine of 2 pi over 3, is that equal to minus sine of pi over 6? Well, both these values are on our unit circle. Cosine of 2 pi over 3 is negative 1. So the value for minus sine of pi over 6, so we're going to have minus, and then the sine of pi over 6 from the unit circle is 1/2. So in this case, they both equal each other, so therefore x equals pi is a solution. So now we're going to take that theory and what we know, and we're going to extend it further. So we want to find all solutions of the equation tangent of x equals 1. So what we need to do is we need to take the inverse tangent of both sides. When we do that, the left-hand side becomes x, the right-hand side is inverse tangent of 1. So when we think about this, we know that inverse tangent is only defined between negative pi over 2 and positive pi over 2. So with that being said, the only value that is an acceptable answer inside of the inverse tangent's domain is x equals pi over 4. Now, it tells us to find all solutions. So anytime that we have to find all solutions, we need to add in plus the period of our function. Well, the period of tangent is pi, and then I'm just going to put an arbitrary n here. And in this case, n equals 0, 1, 2, and we can keep going from there. So our answer is x equals pi over 4 plus n pi, in this case right here. So anytime it says all solutions, we're going to have some type of n pi or 2n pi that we're going to have inside of there. So again, we're talking about all solutions. So 2 cosine x plus pi over 3, or square root of 3, sorry. So that means that 2 cosine x equals negative root 3. Cosine x equals negative root 3 over 2. So x equals inverse cosine of negative root 3 over 2. Now, inside of this type of problem, there are two spots where inverse cosine of x is equal to negative root 3 over 2. We're going to have 5 pi over 6 and 7 pi over 6. Both of these cases will give us the solution to this right here. Now, the period of cosine is 2 pi, so we're going to add 2n pi to each one of these in each case because, again, we're finding all solutions. Now, on this next one, it says find all solutions, but it says inside of this interval. So when we're talking about inside of the interval, it's slightly different. The first cases, they're going to be 100% the same. We're going to do the same process. So in this case, though, we're going to have 2 theta equals inverse sine of root 3 over 2. So I'm going to work with this right-hand side first to know that the right-hand side answer is going to be pi over 3 and 2 pi over 3. But in each one of these cases, it's 2 theta equals that. And if we just find all solutions, if we just stick to that piece for right this second, we would then say plus 2n pi and plus 2n pi. But in each one of these cases, it's 2 theta equals that. So we need to divide everything by 2 theta, or by 2, sorry. Sorry about that. So that means that theta equals pi over 6 plus n pi, and theta equals pi over 3 plus n pi. Now, that was just to find the all solutions piece. Now, we have to check to make sure that our solutions are inside of the closed interval from 0 to the open interval of 2 pi. So what we want to do here, we want to plug in specific values. So let's start with n equals 0 and see what happens. All right, so we get pi over 6 and pi over 3. Next, we're going to let n equals 1. So that means we'll have pi over 6 plus pi, and we'll have pi over 3 plus pi. So in this case, we have 7 pi over 6. And in the second case there, we have 4 pi over 3. Both of these values are inside of 0 to 2 pi. Now, when we let n equal 2, we would have 13 pi over 6, and we would have 7 pi over 3. But if we convert this back to sixths and thirds, 2 pi is equivalent to 12 pi over 6. So this value is greater than 12 pi over 6. And in terms of thirds, 2 pi is equal to 6 pi over 3. This is greater than 6 pi over 3. So in this case, we do not care about the n equals 2 case. And anything above that will also give us stuff outside of it. So my 4 solutions in this case are pi over 6, 7 pi over 6, pi over 3, and 4 pi over 3 will be my only solutions to this equation. So again, we're told find all solutions, but we're bound to this interval. So in this case, x over 2 is equal to inverse tangent of root 3 over 3. So that tells us that x over 2 is equal to pi over 6 plus n pi. And x over 2 is equal to 7 pi over 6 plus n pi. So this tells me that x equals pi over 3 plus 2n pi. This tells me that x equals 7 pi over 3 plus 2n pi. So now, n equals 0 case, we're at pi over 3 and 7 pi over 3. But 7 pi over 3 is already greater than 6 pi over 3. So we don't care about that value. Obviously, if we add a 2 pi to anything, we get 7 pi over 3, which we had already concluded was not in there. So my only solution inside of the given interval is pi over 3. So we're told, find all solutions again inside of a given interval. In this case right here, it looks to be like we have a quadratic style. You can either use substitution to simplify and then sub back in, or we can work it at face value. So if we work this at face value, this factors to 2 cosine x plus 1 and cosine x plus 1. We can set each one of those equal to 0 and solve. So the first one gives us cosine x equals negative 1/2. The second one gives me cosine x equals negative 1. So for the cosine x equals negative 1, this tells me that x equals pi plus 2n pi. For cosine x equals negative 1/2, this tells me that x equals 2 pi over 3 plus 2n pi, and 4 pi over 3 plus 2n pi. So for all three of these cases, so for n equals 0, we get 2 pi over 3, 4 pi over 3, and pi. For n equals 1 case, so we're adding 2n pi, we get 8 pi over 3, we get 10 pi over 3, and we get 3 pi. All three of these values that we found for n equals 1 are greater than 2 pi. So our only solutions are 2 pi over 3, 4 pi over 3, and pi. We can do the same thing with values that are secants instead of sines and cosines. It doesn't really matter. So, easiest way that I have found to work this is, why not break this apart? Let's make this back into cosine. So how about we make this 1 over cosine squared x minus 2 equals 0. Then we can say 1 minus 2 cosine squared x equals 0. 1 equals cosine squared x, or 2 cosine squared x. Cosine squared x equals 1/2. So that would mean that cosine x equals plus or minus the square root of 2 over 2. So that means that we really need to solve cosine x equals root 2 over 2 and cosine x equals negative root 2 over 2. In the first case, this would tell us x equals pi over 4 plus 2n pi. In the second case, x equals 3 pi over 4 plus 2n pi. And of course, in each one of these, we also have 7 pi over 4 plus 2n pi and 5 pi over 4 plus 2n pi. When n equals 0, we have pi over 4, 7 pi over 4, 3 pi over 4, and 5 pi over 4. Anything that we add 2 pi to is going to be outside of my interval, so these 4 values are the only answers that we have. So we're told, find all solutions again in this interval. Sine of x equals negative 2 sine x cosine x. So first thing I do, I'm going to get everything on one side. So sine x plus 2 sine x cosine x equals 0. Factor out a sine x. So you have 1 plus 2 cosine x equals 0. So this means that sine of x equals 0 and cosine x equals negative 1/2. So sine of x equals 0. So x equals pi over 2 plus 2n pi and 3 pi over 2 plus 2n pi. That's not right. Sine of x equals 0 at 0 and pi. Sorry about that. Cosine of x equals -1/2. So that means x equals 2 pi over 3 plus 2 pi and 4 pi over 3 plus 2 pi. So when n equals 0, we have 0 pi, 2 pi over 3, and 4 pi over 3. Obviously, if we add 2 pi to 0, we get 2 pi, but we don't include 2 pi by my original interval. And if we add 2 pi to anything else, it's outside of that. So therefore, these four are our answers: 0, pi, 2 pi over 3, and 4 pi over 3. So just like in a second ago when we did it with cosine, now we've got a mixed sine squared and cosine. There's no way to change a cosine into a sine, but there's a way to change sine squared into a cosine squared. So we're going to make this 1 minus cosine squared x minus 2 cosine x minus 2 equals 0. Then I'm going to make this into cosine squared x plus 2 cosine x plus 1 equals 0. We can then factor this. Cosine x plus 1, cosine x plus 1. Notice that each one of these parentheses is the same thing. So in essence, we're just really solving where is cosine x equal -1. So x is equal to pi plus 2 pi. So when n equals 0, we get pi. We add 2 pi to anything, we're outside of our interval. So pi is our only answer here. So we're told sine of 2x equals cosine x. We have a double angle, so we need to get it out of that double angle. So we know this is 2 sine x cosine x equals cosine x. We can subtract the cosine x over to make this 2 sine x cosine x minus cosine x equals 0. Factor out a cosine x, so we get 2 sine x minus 1 equals 0. So we want to know where is cosine x equals 0 and where is sine of x equal to 1/2. So cosine of x equals 0 at pi over 2 plus 2 pi and 3 pi over 2 plus 2 pi. Sine of x equals 1/2 at x equals pi over 6 plus 2 pi and 5 pi over 6 plus 2 pi. When n equals 0, we have pi over 2, 3 pi over 2, pi over 6, and 5 pi over 6. If we add 2 pi to any of those, we're outside of our given interval. So therefore, we have nothing else that we can do there that will give us any more solutions. For our last example here, we're told use a calculator to find all solutions of the equation inside of 0 to 2 pi for our given value here. So if we just solve this at face value, if we just look at this and we pulled up our calculator, and when we pull up the calculator to get this answer, so x equals inverse sine of -0.7298, that will give us x equals -0.8180. Now, The problem with that is we need to be between 0 and 2 pi. So once we get our answer here, we have two things we need to do. Negative 0.8180 plus 2 pi is going to give us 5.4652. This is our first answer. Now, we also have another one that we can do. So in other words, if we kind of remember our unit circle, so if we have x equals a negative here, by adding 2 pi to it, we got back to the same value. That gave us this answer that we just found. In almost all cases, or in all cases, we also have one that's on the other side over here. So if I just add pi to it, that puts me on the other side. So what we really want to do is we want to take pi minus a negative 0.8180, which is the same thing as pi plus it. And therefore we get 3.9596. And that is our other value. That will give us the same exact value. Because remember that for sine, that's the y value. So if we're down here and we need a negative, we also have one that's over here. That gives us the same y value and everything. So therefore, the two solutions here would be 5.4652 and 3.9596 and everything. So it's going to take some time. You're going to get a hard lesson in using your unit circle in this lesson right here.